All right. Well, Carl, we have our Ford Excursion Club that has got a lot of questions about TX7 that they have posted to our Facebook page, and just want to address some of those questions with them today. And thought you might be the best person to do that since you made the stuff, you created it.
Absolutely. Good to do this.
All right. So our friend Vale, he started with showing a bottle of TX7, and some people have commented some different things. The first one is, what does it do and why is it different? What is different about it?
Well, TX7 is a mixture of several different unique ingredients. One, it has a fluoropolymer in it. Fluoropolymers are lubricating particles. They are synthetic in nature, and because we use virgin material, they're easily burnished throughout the engine. So we use the mechanical interaction of the motor and the high friction points of the motor to actually smear these particles into the microscopic imperfections of the metal. After doing that, then you've got a material that actually will attract oil to the surface itself. But TX7 goes further than that. We have a material that fortifies the film strength of the oil. So under high load and high temperatures, the oil, whatever the customer might be using or putting TX7 into, actually gets better. So you have a more stable film strength, which is ultra important to keeping the wear that can occur whenever engine parts touch each other during operation. And a lot of times that occurs when the motors get really, really hot, whether it be in a Texas highway standstill affair where it's 100 degrees outside and you're not about to turn the air conditioner off and the cooling system's doing everything it can, and the oil system is really almost maxed out, we would say sometimes, by the temperature of the material. It will keep it stable and keep the lubricating qualities at a very peak level that's unobtainable in no other way.
All right. What about our friend Kevin? He's been using it for a little while now. He says, all I can say is my V10 used to burn about 1 quart every 1,000 miles, but last month he ran a 5,200 mile trip in 3 days and only used up about 1 quart of engine oil in 5,200 miles. So can you tell me why? Why would that be?
And the reason that occurred, sometimes people refer to what goes on when the polymer burnishes in the engine as, say, sealing up some components, whether it be ring lands or helping out in valve stems or actually helping out with the piston inside hydraulic rollers. But what's happening is the polymer is plating out, let's say in a ring land area, and that ring land is a groove, and you've got a ring in there that moves up and down as the motor does what it does. And this surface right here, this bottom surface, is actually a seal surface. So the ring needs to move, needs to orbit, needs to go in and out, and by utilizing TX7, you're able to keep the ring functioning at the level it was designed to do, rather than sticking from possible coking by either consumption of oil that would go under the ringland, around and into the combustion chamber, or fuel. But most of the time it's lubricants that will cause the coking. And if that occurs, if that coking occurs, it can stick the rings, or it can create some particles being implanted into this bottom surface of the ringland. And if that occurs, then the ring seal surface is not nearly as good. Now, diesel engines, they've taken that situation, and so they have an iron ringland that has been casted into the piston itself. No gasoline motor's ever gone that far, but with diesels, because they run on compression, it's real important to try to keep that seal surface of that ring and ringland as clean as possible. And diesels even use what are known as keystone design, which actually causes the ring to self-clean that land all the time. So unique technology that the diesel industry is adapted to.
So our skeptic today seems to be Brandon Gerber. He says if you put it in your engine and it's capable of sealing up piston rings or valve seals, what else is it going to seal? It can't be selective about what it seals. So it can seal anything that's in its path, even things that aren't meant to be sealed. I work on these things every day. I see what miracle in a bottle can do. You like it being called a miracle in a bottle. You think it is a miracle in a bottle, huh?
Well, if you want to call it a miracle in a bottle, I'll take that. I know it's technology in a bottle more than anything, because there's nothing like TX7 on the market. It was designed to cure a particular problem with synthetic motor oils in racing engines that use solid lifter camshafts. And because of the lack of paraffins in that formulation, the camshafts would wear out prematurely. I mean, they'd barely make 500 miles and they were gone. Well, the source of sludge, which is the paraffins and mineral-based oils, is a key ingredient to keep a flat-tapped cam or solid lifter camshaft alive. So we stepped it up a notch. We're using a fluoropolymer particle, very, very small. In fact, half micron inside. There's no oil filter that will stop TX7. It goes right through. But at the same time, it's easily burnished, and this burnishing is a unique form of lubrication. And that lubrication particle on a camshaft did its trick in the synthetic lubricants. The cams didn't wear out anymore. So we achieved one particular thing. Now, talking about utilizing TX7 in an engine that's got a lot of miles on it. Well, the only way you can honestly measure the condition of a motor is called soluble oil analysis. Caterpillar developed it. It is a great way of telling you how's the motor doing. So you take the used motor oil, you run it through this spectrometer or gas chromatograph. I'm not sure which one of the machines is actually used, but what it does is it tells you parts per million of what's in the oil. So let's say you've got a certain level of aluminum, well, that's off a piston, or a certain level of cast iron, which could be off the camshaft or the cylinders, or a set of chromium, could be off the stems of the valves, or materials such as lead or Babbitt material coming off the bearings. Maybe you got some copper. Where'd that come from? Thrust bearing in the crankshaft unit. So all of these things tell a story, and that story tells you how the engine is performing. So we may have a standard parts per million that we see every time we change the oil, and that's normal. But what's unique with TX7, once that material is put in there, the numbers go the reverse. All of a sudden, the soluble wear metals are not present. So it's just simple. It's not rocket science, it's just common sense. We're changing the way the wear patterns in the engine occur. I've even done this in some Ferrari race cars, and we got the numbers down so low that we analyzed the oil that we were using, and we found out that what we were seeing was actually in the oil itself. And that can be an anti-wear package that the manufacturer selected to help reduce the wear in the engine.
So Brandon's next comment was, so, you know, all that's good and all, but this is made for engines that get rebuilt frequently, not engines designed to already run 200,000 miles. So my question then is, on top of Brandon's, is what's going to be different about an engine that's, let's say it's built to be run for 200,000 miles, and at the end of 200,000 miles, if you ran TX7 the whole time, what would be the difference between one that just ran conventional oil and one that ran TX7?
Well, I can tell you, because I've gone into motors that have an extensive amount of age on them and mileage. And two identical motors that I looked at, real simple ones, 350 Chevrolets. One motor had 150,000 miles, the other motor had 145,000 miles. Well, the one that had 150,000 miles on it, after being rebuilt, and it had TX7 put into the motor every oil change. Now, I just suggested it so that he would get the maximum benefit on wear reduction in the motor. And it doesn't really matter if it's a rebuilt motor or a new motor. Once the piston ring has sealed to the cylinder, which means the motor is broke in, then you use TX7. And getting back to that question of sealing things up,
right,
whether it be a ringland, a seal, on a valve stem, whether it be the valve guide, where you can get some burnishing in there and help tighten up that clearance, or even the piston inside of a lifter. We've heard numerous times that putting TX7 in a motor that has a lifter tick because the piston's not sealing up correctly, and so it's not holding the pressure necessary to do its job. Well, we've improved that remarkably. I will just tell you this. When it comes to TX7, if you've got a wore-out motor, or you've got a motor that's got broken parts, it won't fix it. In fact, I don't really take much credence to anything that you pour into a motor when you're trying to fix a mechanical issue.
Right. Okay. So Nick says, I do agree some sealing agents are bad for your engines as others are not, just have to use the right stuff. So how is this different than something that you might see that's going to seal, do some type of sealing in the engine?
Again, this gets back to the fluoropolymer. It's very, very soft. It's a virgin material. It's almost like candle wax. If you would take a candle and put a drop on say a hard metal table or something, and you took your finger, of course it'd be hot, but if you took something to protect yourself, you could smear that candle wax. Well, we're doing the same thing with the polymer. We're smearing it. I could use the term burnishing it. So we're actually using the mechanical interactions of the engine to make this polymer smear onto the high friction points, whether it be the engine bearings, real important. Piston skirts, real important because of all the friction there. The ring lands, yeah, friction. It's a phenomena that the automakers are trying their best to reduce in all engines by going to tighter clearances, smaller rings, smaller piston skirts, roller this, roller that, trying to take the friction out of the motor. Well, I can tell you, with TX7, because it changes the frictional properties of the lubricant, you will see a much more efficient engine in that when I took these motors apart that I looked at, the 150,000 mile motor that had TX7 in it all the time, the crosshatch was still in the cylinders from when we honed it and put it together. The bearing clearances, I could not hardly measure 1/10 of a thousandths wear on any of my bearings. Yet the other motor that only had 145,000 miles, the bearings were worn through the copper, the rings were stuck, the piston skirts had some scuffing on it. Well, these two trucks basically were in a fleet where who knows who drove them. Not anybody that cared about the vehicles. They were just vehicles that had a job to do every day. Well, because of the results that they got on the vehicle with TX7, now every vehicle in their fleet uses TX7, and people ask the question, oh, will it last for 50,000 miles? No, it won't last for 50,000 miles, but it will last for 22,000 miles, and we figured that out through oil analysis. When you started seeing the metals go back up, well, the polymers wore out, because every time you change the oil, there's a certain amount of detergents that are in the oil to keep all the guck and goop suspended, so that when it's time to change it out, it goes out the oil plug and all the big stuff gets caught by the filters.
Great. So the last question and I think you may have already covered this, but Brandon also says, so how does this product seal up piston rings and valve seals, but not oil passages and pickup tubes? I think you've already
Sure.
that.
But let me tell you, back when there was a product on the market that did not use a virgin polymer. In fact, they used what is known as reground polymer scrap, and they also used the wrong kind. Well, when a polymer can actually be compression molded into a solidified form, taken from a powder to a solidified form, and that's how you see some parts made out of a thermoplastic. And there was a company, they're still out there, that buy all the scraps or the reject parts and then they grind them all up. Well, when you thermally convert this material from a powder to a solid and think it's going to go back to the same type of characteristics as the virgin material, you're sadly mistaken. It's not even close. In fact, it's too hard, it's too tough, and for some strange reason, it almost has a polar attraction to itself. And yeah, it does congregate. And yeah, I've heard it plugging up things. But TX7 polymers don't do that at all. The particles, even though they stay in suspension, they're actually used by the motor in the ways that I was discussing earlier during the burnishing process.
Okay, and then the last question that's been asked sort of throughout the whole thread is, how much am I supposed to put in there? Because most people are pretty, well, let's try it. I mean, it can't hurt.
Sure.
How much
Here's
do I
my
use?
recommendation. I'm a 7.3 Ford diesel guy. That's what I like to play with. It's got a 15 quart capacity. Well, normally I say 20% the total volume of the crankcase will give you the hit or give you the type of effects that I've been talking about. Okay, so Power Stroke Ford's got 15 quarts. We'll put 2 quarts in to start off with. And then what do you do after that? In my opinion, get out on the freeway, drive it 30 minutes one way, 30 minutes back. Now you have operated the motor at RPM and temperature so that the polymer has really done its thing. In my opinion, the guy that's going to have the hardest time seeing what TX7 is going to do for him, he gets in his vehicle, starts it up, drives 5 miles, he's at work all day, drives home, and at the end of the week, he does his gas mileage. He never had the motor up to operating temperature. It never was efficient as it's supposed to be.
Okay, so just 20% of the full
Right.
volume.
Now, getting back to putting 2 quarts in to start off with. Now, do you need to put it in every time, 2 quarts? No. In fact, depending on how you use your vehicle, let's put it this way: if you're that guy that goes on 5,200 mile trips, he's driving his vehicle. He's using his vehicle. Is he abusing his vehicle? No, he's not abusing it, but he's working it, and working it is to get something done. Get to the trip, pull the trailer, who knows what.
I think he did pull a
Got
trailer.
a load
yeah.
in there.
Yeah, I think he had one.
So it's what that vehicle is designed to do, and all we're doing by putting TX7 is enhancing the efficiency of the engine by reducing friction, increasing the durability of the engine by reducing soluble wear metals, and I'm telling you, it's easy to prove. Anybody wants one, we'll send you an oil analysis kit so you can see it. But the bottom line is, one thing about racing, and I'm very proud of our racing heritage, those guys can tear up stuff way faster than anybody else. And when they race, they know exactly what they've got on Monday. And a lot of times they'll comment, the motor is very good shape.
All right. Well, I appreciate everybody having comments, and you guys keep them coming, and Carl can keep addressing them as we go.
Hey, I appreciate you guys letting me talk to you today. Have a great one.
Okay.